So yes, up to now we've been talking about static electricity. Okay, guys, there's 3 of you there, which is a little crowded, and there's a space in behind. So either cut it out or voluntarily spread out before I make you do it. Okay? So, today we're going to talk about current electricity is. We're going to understand how static and current are related, and you're going to be able to solve current electricity word problems using this formula, I equals Q over T. You have now graduated to the solving problems in science class.
Math?
Hooray! Yes. Science is really applied math.
I just like math.
It's just multiplying by, you can do it. Okay, so you have a handout right there. You're going to follow along, fill in some notes, and then we're going to give you an opportunity to practice a little bit later. Do you like my little joke?
Yeah.
Sparky, your mother and I am shocked at your current behavior until you learn that's the same
Until you learn to conduct yourself properly, you are grounded.
Wah, wah, wah.
It's funny because he does have the crown wrong.
Yeah, I know. I like it. I like the fact that his name is Sparky.
How would you name your kid Sparky? It makes sense.
Okay, so tell me,
I don't name my child.
what do you think here? This is just a what do you think. How do you think static and current electricity are the same? How are they different?
They're still better.
You can borrow it, that's all.
When you steal it, you don't have
This is my
They both transfer
It's on the floor, right?
They both transfer electrical.
Form of electricity, both involve what particle of the atom?
Electrons.
Electrons, that's right. And so how are they different, do you think? Sam, can you finish that up there, please? How are they different? And why do we have to have 2 names? They're obviously different in some way, right? Josh, any ideas? Time?
One is like constant electricity moving, not just staying still and then just
Okay, exactly. So would you say it's a little bit broken there, Taylor? Do you remember the electrophorus high plate demonstration?
I know.
We charged the styrofoam by rubbing it, and then the charge was transferred to the metal plate. It became negative. Electrons moved to our finger, and we got a spark when we touched it. But that was it, right? Spark, that was it, right? If you wanted that, and then we did it with the light. If you wanted the light to stay lit, you had to keep rubbing it, right? And that's sort of an introduction to current. And then I brought out the Van Rack generator, and we had a great time with that. And that was more like current electricity, because if you put your finger out, it would keep shocking you over and over again, right? If Keith stuck his finger in the lights, with the outlet there, if he was foolish enough to leave it in there, he would get continually shocked, right? So really, static electricity is just taking, or current electricity is taking that static and continuing that demonstration. Oh yeah, I've got this here,
Have you
right?
seen the videos of the kids like taking this like metal thing and then sticking it in and shocking themselves and then
Not a good
so
idea.
funny.
Oh, I did that in the basement going into water.
Not a good idea. Okay? Alright. So, did I do the pie plate thing?
No,
I didn't, did I?
did not do that this class.
Okay, I promise I will do it at the end of the class if you guys can get all that 6 problems
We'll
done.
do the Van de Graaff.
I will get the graph out again, and I will do the pie plate demonstration. It's very cool.
We'll do the fan graph too.
I will. Well, we've already done it.
Well, we'll do it again.
Yeah. Okay. There might be time. We gotta get the worksheet done. Okay, so current electricity is defined as, here's the part where you guys are writing down. Current electricity is defined as the amount of charge per unit of time. Amount of charge per unit of time. And there's the formula right there. Using your thinking skills, what do you think the letter I represents
Indigo.
in this situation?
That's what it means?
No, it is the current. I stands for current.
It's like, what do you think I means? Current. Why'd you put C?
What would I use for charge then?
I.
Oh.
Where's charge on there? Q is Q?
Charge is Q.
Charge is Q.
What is this? What is this?
Well, okay, but time, T, is time. Now, the reason that they don't use C is, you know the famous Einstein formula E equals mc squared? What does the E stand for?
Electricity.
The velocity.
Eggs.
Not eggs.
Like velocity. Power.
Energy.
Energy.
Energy. What does the M stand for?
Mass.
Mass. What does the C stand for? Of?
Speed.
It is speed. It's the speed of light. C is a special constant for the speed of light. Why they use C, I don't know. Probably because L would be look like a 1.
Why do you use like
S looks like a 5. They use C for the speed of light, and because the speed of light is so important, they don't allow it to be used for other ones. So they use Q for charge, and they use I for current, and I have no idea why. There's probably a reason. It's probably got something to do with Latin and guys with fancy hair. I don't know.
Einstein was new.
Oh yeah, so you need to know that I is equal to Q over T, Q divided by T, and that's current is equal to charge divided by time. Because current is the amount of charge, what does the word per mean? Karen, what does per mean here? What is the word per? Charge per unit of time. Well, it means divide by. Per means divide by, right? Meters per second mean how many meters in every second? How much charge in every unit of time? Okay, now, there are other versions of the formula which you should write down. Those of you that might have a little more advanced math skills would know how we come up with these formulas. Q is equal to I times T. You're going to multiply both sides by T. Q equals I times T, or T is equal to Q over I. Do the Q and the I and the T all stand for the same things? No, they do.
What?
Right, so you're going to write that down there where it says other uses.
I quit math. What is school?
They all mean the same thing, so Q now means, yeah, it's the same.
Q, T, and I mean the same thing.
No, now when it's Q, it actually means.
No, when Q means.
No, when it's Q, now it actually means.
No, Q is always turn.
I'm just
Yeah.
joking.
Everybody's like, joking.
No, I should really get the message.
Yeah.
No one changed it.
Come on. I know.
Yeah, where you going, sir?
Scared.
Yeah, right. No balls. Right. No balls. No balls. No balls. Well, there's the balls. No balls.
Hey.
No balls.
No,
they wouldn't be in.
I would like you to realize the time is always measured in seconds. Time is always measured in seconds. And please note that there are 60 seconds in a minute,
Really?
60 minutes in an hour, which means there are 3,600 seconds in an hour. Really? What is like
One Mississippi, two Mississippi, three Mississippi. So if I count 3,600 Mississippi.
3,600 Mississippis in an
That's an
hour?
hour.
Okay.
That's what you want to stop.
Let's do some sample time conversions because you're going to have to be able to do these as well. Okay? So, how many seconds in 4 minutes? Are we on the next page? Not yet? No, we're not.
400.
How many seconds in 4 minutes? All you do is 4 minutes times
60.
60 seconds. 240 seconds. Pretty easy, right?
Yeah.
May not even need a calculator. If you need one, that's fine too.
Yeah.
I left a lot of space there, didn't I?
It doesn't matter.
How many seconds in 0.75 hours?
That's 45 minutes.
That is 45 minutes, right? If you don't know that 0.75 hours is 45 minutes, how would you do that? 0.75 times
Why?
60,
Then you move the decimal, and then you multiply it by 60.
45 minutes, and then 45 times 60. That one I can't do in my head.
What if I'm so smart I can do it in my head and then I don't have to show my work?
Show your work. Always. It helps me understand what you're doing. If you get it wrong, I can't understand what you know. Show me your work. I've done this 4 times already this year. I'm asking you to do it once.
I'm doing math.
And I know how to do it.
I'm doing math every second day.
So those are just some sample time conversions that you need to be able to handle. Okay? I expect you to be able to do those. Woo! Sorry about that.
Maybe that wasn't your phone.
It's resting safe in the timeout basket.
It's okay.
Okay, now, some of you are not going to be happy with this, but I'm going to insist and I'm going to win. These are the steps for solving electricity problems.
I'm the captain now.
You've got them right there. I've given them to you. I've told you those are the expectations. You will follow them. Yeah, absolutely.
Debbie, you can write anything.
You can write anything you want on yellow on those sheets. Yeah, absolutely. Okay, so all problems, and you're going to get a chance to practice too. All problems must be solved with the following steps to get full marks. So I expect you to state the variables, given numbers, and the unknown variable. Okay, and I'm going to show you, I'm going to do a couple examples right away for you. Okay, so I expect that to state the variables and the given numbers and what's unknown. Write the formula to use. I still fight with my grade 12 physics kids over this. Most of them have learned that it makes things a whole lot easier if you write the formula. Because when you get a 12-step problem, well, the kids that can't do it just get 0 because they can't do it because they still, I'll just times it and multiply and then I'll give you the answer. No! It doesn't work. Yeah, a little bit too much talking there, kids. Substitute the given numbers into the formula. I'll show you how to do that. Solve, do the math. Check that units are written after the final answer. Are units important?
Yes.
They are. Tanya, how'd you like 100,000? How'd you like 100,000?
100,000 volts?
$1,000, sir.
Yeah, but what I'm really offering is 100,000 kicks in the butt.
Okay.
Units are important.
I've been kicked in the butt before.
Not 100,000 times, I'm sure. Check that all equations have variable symbols or numbers before and after the equal sign. And one more that I like,
Like total
equal signs lined up.
Not at one time.
Nice and neat. Okay, it helps. Trust me. Don't give me the what if. Do it. Are you when you learn how to drive? Are you gonna put your hand up and say, "What if I just don't stop at red lights?" No, it's the law, it's the rule, and you're gonna do it. No! No! No, you're gonna do it. I'm gonna keep making you do it until you do it. Don't look for the ways out, just say, okay, I can do that.
No, what do you guarantee if we don't do it?
I'm gonna make you do it again.
What if we still don't do it?
I'm gonna make you do it again. Here's a sample question. I'm now going to show you what I mean. And then you're going to do some of these. Vinny, put the phone away. Here I have a circuit. Okay, now you need to learn a few more things as well. If 240 C of electric charge passes a certain point in a circuit in 5 minutes, what is the current through that point? Okay, there's a lot of words there, right? Okay, good point. Excellent. The big letter C is, this one right here, is coulombs.
Okay then.
Coulombs is the unit of charge.
True.
Coulombs, named after Charles Coulomb. So it's 240, was he cool?
No, do you have long hair?
Oh, of course. They all did back then, right?
Good.
240 coulombs of electric charge past a certain point in a circuit in 5 minutes. What is the current through that point? Okay, so what were the 3 letters that we had? We had I, Q, and T. Do we know the I?
No.
We do not. It says, what is the current through that point? So we do not know I. I'm going to put a question mark for I. Do we know the Q? Q stands for charge. What's my charge? 240 coulombs of electric charge. Q is equal to 240. It's given in the question. In a circuit in 5 minutes, that is my time. Now, unfortunately, it's not given in seconds, so what do we have to do? Take that 5 times by 60, and we get 300 seconds. Okay,
Wow.
I'll pause for a second there. I'm going to go back to the steps. Have I stated the variables given numbers and the unknown variable? That's what I just did. Step number 2, write the formula to use. You've only got one up to now. Which one has I equals in it of those 3 that are all the same? Right? It's this one, right? I equals Q over T. So I'm going to write I equals Q over T. And the reason you write that is to say, Mr. Bennett, I understand this is a curve problem, and I'm going to show you my thinking. I'm going to show you the formula. Okay? And that way, if you make a math mistake later, I can say, well, they obviously know something. I can give them some mark for that. You got to do it. That's step number 2. Step number 3, substitute the given numbers into the formula, keeping the equal signs lined up. Now, there's always someone that likes to do this. For some reason, everything has to be over on an angle.
What has,
I don't know why. Their whole solution goes like this for some reason.
I love doing that.
I don't know why, and it makes no sense to me. Some people like to write it out in a nice line because it fits on loose leaf nice, right? I know those people. Those are the loose leaf savers, right? They go through like 4 sheets of loose leaf in the entire year. Okay?
Okay.
Don't worry about it. I got lots of loose leaf.
Can I go to the
Line them up. Oh no, you don't want to go down.
Why?
No, you got it here.
How many
So,
minutes? 5?
yeah, maybe 5.
Okay.
I equals Q over T. What's my Q? 240. Notice how I lined up my equal signs. 240 over, now which T do I use? The 300, because it's got to be in seconds. 240 divided by 300, and then you're right, I equals, exactly, to do the dividing, 0.8. Now, it's not C. Current is measured in amps. We use the letter A.
I thought it would be like Z or something.
I know, it's all sorts of crazy. Amps. Ampere. I can't remember his first name. Another French guy. We might want to go back. Can we go back to here? Can we go back to here and write that I is measured in amps? Give me a second, T. And Q is measured in coulombs. And I know it's hard to understand. I get that. T is measured in seconds. And keep in mind, you can write anything you want on any of those yellow sheets and use it on the test. I'll pause there. So if you haven't had a chance to write that all down, now is your chance to write that down, right? I equals Q over T, I is equal to 240 over 300, 0.8 amps. You can just write A for amps, just like that. Did I state the variables, given numbers, and the unknown variable? I did. Did I write the formula to use? Yep. Did I substitute the numbers into the formula and solve? Yep. Did I write units after the final answer? I did. And did I check that all equations have variable symbols or numbers before and after equal sign? What that means is some people like to do this. I'm not that big of a stickler on that. I'm okay with that, actually. It's not technically correct because how can 240 over 300 be equal to nothing? But for the most part, that's how it should look. I also like if the answer's sort of underlined or boxed or circled or whatever, right? It's not a big deal, but okay.
Equals everything? Okay, I'm gonna go to the
Yeah, I guess if you really. Are you ready to try an example on your own?
No.
No? I should do this one for you?
What's the answer? What's the answer?
Okay, let's do number 2.
Am I right, number 2?
I don't know. I'm going to work it out. Let's look at number 2 here.
Well.
If a stereo in a home is on and uses, or sometimes they use the word draws, 12 amps for 30 minutes, how much charge in coulombs is this? Okay, so again, I need you to write down the 3 letters. Bailey, you can write down the 3 letters. They are I, Q, and T. Go ahead, Bailey, you can write down I, Q, and T. It draws 12 amps for 30 minutes. 12A. Which of the letters is that? That's the I. 12 amps. The Q. How much charge is this? Do we know the Q? We do not know the Q. Question mark. Do we know the time? Yes. 30 minutes. Again, it must be in seconds. It's just the way it's defined. So 30 times 60 is? Well, 3 times 6 is 18. Is that right? 1800 seconds. Okay. I need the formula that solves for Q. Q equals I times T. Write the formula. If you want to put the little multiply sign in there, that's fine. If you don't, also fine. I like to write just IT. But if you feel the need to put the multiply, go ahead. Yeah, exactly. I'll take you outside and teach you a lesson, like solving Q equals IT problems. Oh yeah, hang on, that's what I'm doing right now. I is equal to what? 12. What is T? 1,800. Do a big multiply. Ooh, that's going to be a big number, isn't it?
21.
21,600. 21,600 what? Charge is measured in coulombs. It's kind of fun to say. 21,600 coulombs. Is this hard?
No. It's like math.
Yeah. I'll show you grade 12 physics sometime.
Yeah.
Do you want to try the third one out? You guys try the third one. I'm going to go mark my attendance, then I'm going to come back and I'm going to do it. You try the third one on your own. Okay, let's have a look at number 3. How long will it take for 12 amps to move 1,600 coulombs of charge? That's kind of the words they use, move. Again, write out the letters. What are the 3? I, Q, and T. Does it matter what order you put them in? No, I don't care. How long will it take for 12 amps? That is the current, the I. The Q is 1,600, and we're solving for time. Question mark. What's the formula that solves for T? T equals Q divided by I.
What if you're supposed to access? Is that in seconds?
Yeah. Already.
Why do they just use seconds?
What do you mean?
Why can't they just use minutes?
It's the way that the amp is defined as current. It's just the way that amp is defined as charge per second.
It's just the way the guy made it.
Well, it's because electricity moves really fast, right? And so the time is usually in seconds. It's a really small one. Otherwise, hours would be 0.00000.
That'd be good.
Yeah. Okay, so the Q here is 1,600, and the I is 12. More or less, the equal signs are lined up. What was the answer, Terry? You said it was some sort of round decimal number?
It's 133.3 repeating.
One what?
133.3.
130. Can we just round it to 133.3 seconds? That's close enough for me.
3 and then a dash.
That's close enough for me. Yeah, I'm not going to get into all that.
Yeah, but a 3 on the
I know. If you, be my guest. It's good. Okay, you need to be able to solve problems for I, for Q, and for T. Okay, you now have, can I just borrow for 30 seconds? You now have a problem sheet here. It's got 6 problems. Okay, the answers, Kai, stand up for me, please. Go down, yeah, go over to the wall. Put your hand out. No, your face us and put your left hand out. and point with your finger. So that's those 2 sheets on the wall. Right there. The answers are there. I am a huge believer in giving you the answers for you to check. Okay? Just hang on. Just hang on. If you choose to just go and copy it, that's a mistake. Because that doesn't mean you can do it. Okay? I'm not counting this. On the test, am I going to have the answers posted on the wall? No! You're not going to know what the questions are. Okay? So, you've got a couple ways to check the answers. The answers are on the wall. If you have a smartphone, you can scan that code and you will get the answers.
Don't you need the code scanner though, the app?
Yes, and if you still have problems, you can scan the code at the bottom and there's videos of my delightful voice explaining you how to do the problem.
Last year.
There is no reason why you can't say, I don't know how to do that, because I provided examples here, I've got answers on the wall, you've got access to answers here, and you've got access to videos to show you how to do it.
These nuts.
Now it's your job to learn.
These nuts.
Go.
Thank you.
Excuse me, when elementary students drawing on the board.
How'd you
But
I see.
Look, I got it.
Oh, that's awesome.
Yeah.
You can't even show it.
No, it's not. Oh, it is now.